Hi everyone, this for the next lessons, matrix continue the chapter, the lesson of matrix. This is going to be the second sections, exercise 6.2, the chapter 6.2, okay, the second one. But then we're going to talk about addition, subtraction, and scalar multiplication of the matrices. So we see the example. So addition, subtractions are more the similar, only plus or minus sign. Okay. So then, first of all, we're gonna talk about the example. What is about? For example, the following table show the current stock of color pens at two shops. Okay. So the first table here, the purple table here, is represent the current stock. That mean the warehouse, for example, in the warehouse, and they have the retail maybe, okay, sell shop 1 and shop 2, and they have 3 color of pens, blue, black, and red color. This is the at present time they have now. This in the stock they have. And the green table here is represent what the replenishment have just a line, means like a new cargo, maybe they order or they purchase more cargo, right? After then, this is in the stock, but this one is replenishment. The cargo they just receive, so they purchase more cargo. So that means this company or this factory, just say they bought more in the blue pen, buy more pens in the blue color, 70 pieces. And the second shop, there's buy more 105. Okay, and the black, this one they add more. Okay, and from the red, they buy more 55 and 75 for the second shop, for 55 for the first shops. Okay, so in this one, if once you have in the stock and you want to, and then you purchase or get more cargo like these pens, you just add it up, right? So for example, I give this one, this table, say table, just say table, this table represent S, how about represent S, okay? And this table, the second one here, represent with the matrix number, say this one's R, okay, purchase more. And the pink one is the pens have, so a week later. That means in a week later, these two shops, they have the pens after they have in the stock and buy more, and then final they sold out. They sold some of pens in different color in a week later. So like when they up in a week later, they sold the blue pen colors in the first shop at 83, and second shop they sold it 70 pens, and the black 54, 72, and red they sold out 44 pieces or 80 pens or 80 units. Okay, so in this case, if we did not use the matrix, you have to write the table like this way, so it's more clear and understand. So you can add, like if you want to know this in the current stock, then if you buy more, then you just add it up, right? So you just add it up like a blue pen. For example, you do by manual, okay? Do from the information you have in the table right now. So from S, from the current stock they have, the blue pen, the blue color gonna have what, 30 plus 70, right? Gonna be 100. Like right now you guess it. So this one, we do like this. So we can have like a blue color if after this one 30 and plus 70, so you have 30 plus 70, right? For each color, for the blue color. So this is from the period in the just the current stock, and plus they buy more 70 pieces. And after this one They say so, and 1 week later they sold out 83. So you just subtract like this way. So you can get the final answer, or you can get the really remain of the pens of the blue color at this time after 1 week later. Okay, and the black color you do the same thing, correct? The black color you do the same thing, right? So you're gonna have 20 because they're in the current stock, and you plus more 60 here because by you purchase more. Just say you have more 65 60. This for the shop one, okay? This one, the shop number one, okay? And then this one, after that, 1 week later, you sold it out, so become 54, so minus 54. So this is shop number one. And the red color, you do the same way, right? Right, this one, the first shop, blue color, we have in the stock 30, and then purchase more, become added up, right? And then you sold it out 1 week later, 83 pieces. And the black, then now we do the first shop. So 20 minus, this one should be plus, sorry. 20 should be plus 60 because we have more. The new cargo have arrived 60, and then 1 week later sold out 54. So then you just use calculator. And the red color do the same way. Okay, so in this case you have to do by this way. But the matrix we can do by using the matrix pattern, and I think it's easier to do. Okay, for example, we come to this one. How to do the matrix. So this one, okay. The pink one here, the pink table, maybe we let the whole table here represent with what the alphabet we can use, sold out or same. How about L, or maybe just say A, okay? So, and then after this one, we can write it down, right? In the matrix. So we can have S, matrix X, we can write down, okay? Like now we're gonna write as a matrix for patterns, like in the matrix patterns. So you write S here. S, you write down become 30, 20, 35. Okay. And then below here gonna be 45. You just write the number and the table purple color here. So become 45, and this one 25, and this one 30. Okay. And then this are the one you get more cargo, right? So that means you increase. So then you can write in the matrix pattern gonna be 70, 60, 55, 70, 60, 55. And then this become 105, 65, 75, 105, 65, and 75. So you write the matrix. And then for this one, you write that here. And this one, you write that way. And then for A, for after a week later, you sold it out, okay? So we represent as a matrix A. So you can write in that pattern become 83, have to be the same location, okay? Same position and location. So 83, 54, and 44. And this one left 76, 72, 80. Okay, so you can see the matrix S represent the current stock, and matrix R represent the new cargo just arrived. That means you increase, right? And then A represent 1 week later, the pens has sold out according the number here. So when you count, when you look at the matrix, you can see 30 here count to be the first row, right? first column. And this one, the whole thing, first row, second row, okay? And this one, column, first column, second column, third column. So in this case, you check first row, second row. So we have 2 rows represent. And how many column we have? First column, second column, third column. So we have 3 times 3. This represent R and the second one represent column. R lead in this way, this is R. Lead it down, represent column. Okay, so now this also, you see, have how many? 2 rows, 2 rows, 3 columns, the same thing. And this one, 2 rows, 3 columns. Okay, so you can check that the last period I used to emphasize all the time. They must have the same order, right? This is the same order, correct? So then they're able to plus or minus. So in this case, we can do in both way at the same time. Current stock plus the new arrival of cargo and minus subtract for the cargo was sold it out. What cargo was sold in a week later. So in this case, because they have same order, see that same, right? 2 times 3, exact same order. So then we can continue doing. This one gonna be after this, you want to find the final stock we have after we repurchase, right? And sold out 1 week later. So the metric represent become S, right? Plus R and minus A. So you can write it down in this way, okay? So become 30, 20, 35. And then this one 45, 25, 30, plus matrix R, which means we purchase more, right? The cargo, the new arrival cargo. So 70, 60 here, okay? And then 55. This one gonna be 105, 65, and 75. I need more spaces here. So 75 here. Then minus, okay? Minus A, matrix A is what? 83, I squeeze it down here, okay? 54. 54 here. And then 44 here. And this one gonna be 76, 72, 80, and close the bracket. So now you see S represent this matrix. That means that we purchase more cargo. It represent this one. And matrix A represent of 1 week later the pens was sold. Okay. So now we can simplify, want to find the final stock we have after 1 week later. Okay, so how to do? How to do it? Then you can write the whole thing like this, right? So you can, the same location, 30, 70, and 80, you can rewrite that become 30 plus 70 minus 83. And then second one here, second one, first row, second column, right? We call first row, this first row, second column. So become 20, this one, okay? I write down here. So you're gonna have 20 plus 60 minus 54. Okay, so we use different colors, see. And then 35, 55, and 40, 44, correct? So this one gonna be 35 plus 55 and minus 44. Okay, and then you can use another here. Next, this is gonna be second row, first column, 45, 105, and 76. So you have 45. Gonna have 45 plus 105 minus 76. Okay, and then do next element. Okay, like this one, 25, 65, and 72. So become 25 plus 65 minus 72. Okay, try the next element. This one, 30, 75, 80. Here. So the last one gonna have 30 plus 75 minus 80. Okay, so now we have all of them, all the elements here. Now we just simplify. Let's check 30, 70, 83, 20, 60, 54, 35 plus 55, 44, 45 plus 76, 25 plus 65 minus 72, 30 plus 70, take out 80. Okay, now from this one, okay, just like equation. Equation mean this one, okay, final you're gonna get the answer. So I should draw a line, separate them, so you won't be confused about here. Okay, so now you can use, after this you can use calculator, correct? You can add, simplify it for the first one, what we have. 30, 70, 100. So 100, take it out, minus 85, right? 83, sorry. So we left 17 here. So this one becomes 17. Oh. So we have 17. And next one, the yellow color here, become what? 28, 20, 60 become 80. 80 minus 54, right? So we left 26 for this one. And then see the red color, 35 plus 55, right? And take it out, 44, left 46. Okay, and next one gonna be the blue color. You have 45 plus 105 minus 76, so we have 74 here. And the blue one. Okay, so you have 25, 65, become 80, 80, 90, right? And then take it out, 72. So left what? 18. And the last one, last element. We have 30, we have more cargo, 75, and sorted out 80, so we left 25. Okay, so then we got all the elements here. This matrix. This matrix represent what? Represent the matrix S plus R minus A. That is the result of the cargo left at the last after 1 week, right? So see what cargo left at final. So that's the amount. So you can list 17 mean represent blue for the first shop, and 74 represent for the shop, second shop, for the blue color of the pen, and this is black, right, for the first shop, second shop, and this is the red color for the first shop and second store. Okay, so you observe, when you observe this one, because they are the same order, so that's why we can plus minus. Okay, so in this case, final gonna be they can plus minus, but we don't talk about multiplication, leave it away. So you should have the same order also. That means two rows and third and 3 columns. So you observe 2 rows and 3 columns, 1, 2, 3 also for plus minus, for addition or subtraction. Okay, so then this one we finish addition and subtraction. Oh, sorry. Okay, so we finish this one and this one. Okay, then we go next one, I think. So we finish this one, right? And this one. Then we go next one, scalar multiplication. Oh, before that, maybe I give you some more example about addition and subtraction. Okay, maybe we try some more example for addition and subtraction. Okay, say, maybe write down here. Example, say given. So if, for example, I give you the matrix A. Matrix A, which is equal to maybe here 4, 2, 6, maybe 3, 1, minus 7, something like that. And matrix B, okay. Matrix B, maybe 3, 9, 0. Maybe I load more space. 3, 9, 0, 4, minus 1, 8. Okay. And then also give matrix C. Usually when we write matrix, we represent with the big alphabet, the capital, okay? So this one maybe say the element first row, first column, 3 minus 4 here. And matrix D equal to 1, 6, 7, 12. And then say 5 now, after this 5, for example, A, matrix A plus B, and say B, matrix A plus C. I think this one easy now, right? Correct? You know how to do. And say C plus D. And then say question D, maybe D plus C. Okay. Then find A, B, C, D here. And continue, maybe say also find this a 5, okay? Maybe I erase this one. And also say give if O, this one like O, sometimes they like a big 0, become the now matrix. That means every term is a 0. They also give this one, right? And then they say shows that matrix C plus matrix O equal to C. Okay, so now we start to do this example. Take a look of this. Now you want to do question A here. How? You just write A, B, C like a previous example. So you write this one, matrix A, maybe do this way. A plus B, then you have A is what? 4, 2, 6, 3, 1, negative 7. And then plus matrix B. Matrix B, this one, right? So we have 3, 4, 9, -1, 0, 8. Okay, in this case, you have to check first they have the same order or not, right? Just can plus. If not same, it doesn't equal, the order is not have the same order, then you couldn't plus or minus, have to be same, exactly same orders, okay? Like this one, first row, second row, so we have 2 rows. How many column? 1, 2, 3, have 3 rows. How about this one, B? This is A, okay? This is B. So this one also have 2 rows, 3 columns. Okay, now they are same orders. This one okay because they have same order. Now we can add it up, find the final answer. Okay, so how you do? If you know, you just write down like before. Otherwise, you just do one location here, exact same location. So 4 plus 3 become 7. You can write down right away. 2 and 9 become 11. 6 plus 0 becomes 6. 3 plus 4 becomes 7. 1 plus -1 becomes 0. And -7 plus 8 become 1. Okay, so add minus plus still do the same like algebra. So this is the final answer for question A, which is equal to A plus B, matrix A plus matrix B. Okay, and then do question B. See question B. B, if you do A, matrix A plus C, take a look. A is what? You write down the matrix A. Matrix A we have 4, 2, 6, 3, 1, -7. This is a matrix A plus matrix C. C is this one, right? So you write down 2, 5, 3, -4. Then how to do? You don't forget you have to observe the order first. They do have the same order or not, right? If they don't have the same order, you can subtract or plus, okay? This is subtraction. Maybe I can assign some here become minus, okay? So then this one have or not? Check how many rows and column we have. 1, 2, we have 2 rows. How many column? 1, 2, 3. How about this is matrix A, okay? And this matrix C. So matrix C, you check how many rows we have. 1, 2, 2 rows. How many column? 1, 2, we have 2 columns. So check this one. Both of them are different order, correct? So not equal, right? So then this one is no solution. You can say no solution. Or you can say doesn't exist, either one. Okay, everyone understand now? Because they have different order, you cannot sum it up. Okay, so then B can't. Now we do C, take a look C. If C, question C minus D, maybe I try this one, some minus, okay? So I change this one, okay, become C minus D. So question C, how we do? If matrix C minus D, C is here, right? So write down first. So C is what? Or you can write it down, right? Write it down from here. You can write down, say C minus D. You can write down here and equal to matrix C is this one, 2, 5, 3, 3 and -4. This is a matrix C. And minus matrix D. Matrix D is this one, 1, 6, 1, 6, 7, 12. Okay. So now, first of all, check again. Check their whether same order or not. So first row, second row, we have two rows. How about column 1, 2, have 2 columns. Also 2 row, 2 column, correct? So now they are same. equal order, then we can subtract. So how you subtract? Then now subtract, you have to be careful, okay? Because sometimes they have minus sign. This one minus sign. So you can use from here 2 minus 1. So 2, you can write down 2 minus 1. And then next one 5 minus 6. So you have 5 minus 6. And then 3 minus 7. 3 minus 7. Negative 4, negative 12. Negative 4, negative 12. Okay, then you simplify. So left 1 and negative 1. And this one become negative 4. And this one become negative 16. So this is a matrix C minus D for question C. The final answer. Okay. And then again, if they this one I change to B minus, I change this one become C minus D. For question D, okay, I change to B minus. So we try question D. Okay, question D. D. So you like D minus C. The children the same, okay? They can subtract because same order we know from question C here. But the when result should different because D minus C not equal to C minus D, correct? So the D minus C, you like D first, is what? Matrix 1, 6, 7, 12 to cover the line, okay? And then minus C, matrix C is 2, 5. This one do like algebra, but they have to concern about the location, the position of each element. Okay, then if you simplify step by step, okay? Okay, so become 1 minus 2, correct? 1 minus 2, 6 minus 5. So this one becomes 6 minus 5. And then this one no minus, okay? This one becomes 7 minus 3. So 7 minus 3. And this one becomes 12 minus, okay, this one careful, 12 minus 4, okay? So minus 4 here. So this one become minus 1 left for the first element here. 6, take it out 5, you have 1. And 7 minus 3, we have 4. And this one minus become plus, so add it up, becomes 16. Okay, so you see, then matrix D minus C, compare C and D, not the same. Is this one, of course, for sure, because like algebra, you know, okay? This one not same, okay? Not equal. When they swap the matrix to minus from the algebra. Okay, then we finish A, B, C, D. Now, if next one, the last one here. If this one, right? If matrix, this one, if matrix O or O, right, equal to 0, 0, 0, that means this one we call now NULL. NULL, okay, now matrix. That means every term is a 0. Every elements or entry of the matrix, every element equal to 0. Show that C plus now equal to C. So this one I wrote down here. So from here equal to C or not, right? So you write down C is what? C, this one, correct? C here on the top here. So C, okay? C is 2, 5, 3 minus 4. Plus matrix O or 0 here, this one is 0, 0. So you plus 0, 0, 0, 0. And then you sum it up. So you sum it up, become 2 plus 0 is 2. 5 plus 0 is 5. So you do in the same location, okay? 3 plus 0 is 3 here. Okay, and negative 4 plus 0 is a negative 4. So come out still exact same with the matrix C here, correct? See that? This one have same exact same way. So this is equal to matrix C, which is true. So you just prove that's all true. That's the way to do for this one. Okay. Okay, this talk about addition and subtraction matrix. Okay, this is some example. I combine everything inside, but then you practice question later. Okay. Now we go next. Next one we will explain. One you have if matrix A, B, let's explain previous example. If matrix A, B, and O are the same order, where O is a null matrix. Okay, null means 0. Then you're gonna have the property is matrix A plus O, which is matrix now 0. Now matrix gonna equal to A. The last example we just finished, C plus O. And second, matrix A plus matrix B will equal to matrix B plus matrix A. Of course, right? If plus or plus, so like for example, question 2 here. If you're gonna have for example, you plus like algebra idea, okay? So you have 2 plus 3 will equal to 3 plus 2 also. For plus sign, then they equal to 5. Okay, even they come with the in the matrix pattern, right? But they must be same order, don't forget. That's why I always specific, must be same order, right? Like this one, if 2 by 2, this one should be 2 by 2, so you can plus minus, right? So that you can subtract or plus. But if you plus, okay, plus, no matter you swap A matrix A plus matrix B and B plus matrix A, of course they're equal. But if you talk about negative sign, not same, eh? Negative sign not same, eh? Like A matrix A minus matrix B, you think will equal to matrix B minus A, not like a last example we just finished. Of course not, correct, right? If minus, not equal. But if plus here, yes, they are equal because the plus sign no effect. But when minus, which one come first, which one later, not the same. So this one doesn't equal, it's not equal. Okay, then we see matrix, the third property of this addition matrix. So if you have matrix A plus matrix B, like this one, you can light the brackets. So this is the same. When you plus, still the same, correct? This is a very, how to say, without proof, it's true without proof. But if minus, again, when we talk about minus sign, either one, okay, they, of course, they won't not equal, okay, when talk minus sign, but plus, of course, no matter you plus which one first, they will equal or always, okay? We call associative property, but minus, no, okay, no, not equal. Okay, this is the explain for the properties of the addition and subtraction matrices. Okay, this is a take a look. You can use any number and replace by using matrix. You will get the idea what I just talked. Okay, so we go next one. Next one, scalar matrix. Scalar matrix. Scalar in algebra we call coefficients. Okay, coefficient. For example, say if we talk in algebra, like we say 2x, or right, this two we call coefficients in algebra. Okay, but when you write 2a like this in matrix, this 2 we call scalar. The same position but different name. Algebra we call this one coefficients and this one we call scalar. And then if it has minus, coefficient gonna be, coefficient of this case, right, gonna be -2. And then this one, if you have minus sign, scalar of this one gonna be -2 also. If minus sign, that means you have to carry the minus sign also. Okay, but if plus, you don't need, right? Because we understand for the mathematical laws. Okay, Let's talk about scalar multiplication. Now we see this a property of this one. So most of time in this one they use k. Okay, sometimes I load k in this way. For matrix A and real number k also called scalar. You see that? So this k, like this 2, this number 2 or negative 2, we call scalar. The matrix Ka is obtained by multiplying. Yes, you see that? Negative 2 times A, or like you have 6, like in algebra like this. I mean matrix plus 5b like this. So this one, 6 and 5 is scalar. Okay, is obtained by multiplying. See this 6 times A, 5 times A. Okay, so that's multiplying for element in A by K by mean time, right? Multiplication by mean A times K. That's why we have Ka. Okay, now you see if matrix A and B have the same order again. Again, really important, have to be same order for plus minus. If different orders, no solution. For any scalar h and k we have. See this h, like in this case I give you, right? This one can be h, the number 6 can be h and 5 can be k. Can be any alphabet you can use, okay? But in this handout they use h and k as a scalar or matrix. So first, if you have in this, if they are same order, right? Then k, that means scalar time the whole bracket, matrix A plus matrix B, you can have ka, kb. Okay, so if you like AK, still nothing wrong, right? You like this for scalar only, okay? For this one become BK. See, okay, like when you like 2x, it's the same, you like x2, right? But in this case, we really feel writing because not nice at you like the coefficient or scalar in the font, right? So we instead gonna like this, we like K in the font of the matrix, or like algebra, that means in front of variable x. Everyone get it now? Okay, now go number 2, the same idea. Like this one, right? So you have h plus k, that's scalar. Scalar mean can be any number, any real number, just say that. Can be decimal, can be fraction, can be surge. Surge means like square root like this. Right? Fraction may be like a over b, like a 2 over 3, something. Decimal point maybe can be 0, 5, 2, 6, something, right? That k and h can be all. And this is the same thing when you associate. This one you use k, h time ka, or you can do scalar time it first and time a. They're all same. They're all same, okay? For the scalar, you can write the front and the back, is okay. But again, scalar we like to nicer, and we get used to by writing, we always write in the front of the matrix. If algebra in front of a variable x, y. Again, when matrix, when you, for example, if scalar, for example, scalar h, for example, say equal to 2 over 3. If you like matrix, if matrix, so you have to write like this one. Separate scalar out from the matrix. If you write in this way, 2a over 3. In this case, if in this case, not allowed to write in this way, is wrong. For matrix, you have to write in this one. That means you have to get the scalar 2 over 3 out from separate writing from the matrix. But if you write this way, algebra, okay. Like in algebra, we write 2 over 3x is okay, right? Or you can write it down, say 2x over 3, right? You write separately like this, and or write the whole thing and underline like this, 2x over 3. In algebra, this one okay, but in matrix, no, not allowed. You have to write in this way, take the scalar away from, separately from the matrix. This one algebra okay, okay. This one algebra okay, but not okay for matrix. Matrix have to write separately. Okay, that's all for the scalar matrix. Okay, now we can see maybe some example right here. we can finish very soon. Okay. I give you some example about scalar multiplication. Okay. For example, right? For example, if say if I give you matrix A equal to anything, maybe say 1, 2, 3, 4. Okay, and then 1, 2, then 5. 5. What we can do? 5 maybe 3A's. So in this one right now, A is a matrix, 3 is scalar, 3 is a scalar. Okay, then how you find 3A? Easy, right? You just write 3 scalar in the font like this and represent matrix A is what? 1, 2, 3, 4. Okay, so actually 3A means 3A mean with matrix A plus matrix A plus matrix A, correct? But instead you're gonna write like this 3 matrix and plus plus plus. We can write this way, right? Combine at the then write scalar on the font. So this one you just time in, become 3 times 1 here, 3 times 2 here. So become 3, 3, 2, 6. And 3 times 3 become 9. 3 times 4 become 12. Okay. So then this is the answer for the matrix 3A's. Okay, you can do that way. Otherwise, you can use like if you want to use this pattern, take a long time, right? So you have to like 1, 2, 3, 4 like this, and then plus 1, 2, 3, 4, and then plus, and 1, 2, 3, 4, and then plus. And then after this, you just write the whole thing, 1 plus 1 plus 1 become 3. You can do that way, or you have to write step by step, 1 plus 1 first, plus another 1, and then 2 plus 2 plus 2 here. Okay, and then so on, 3 plus 3 plus 3. And then 4 plus 4 plus 4 in the same location, 4 position, okay. And then you simplify. So this one become 3, this one becomes 6, this one become 9, this one become 12, right? Same, correct? See that? That's the same answer. So which one easier? You pick the way you like. They will get the answer anyway. Okay. Okay. So now this is scalar multiplication. And then maybe see the last example here in the word problem. Okay. So see the word problem here. The number of ships arrive at the harbor, you know, like a port somewhere, every weekday from Monday to Friday. If given in matrix D, the number of ships arrive on Saturday and on Sunday is given in matrix E. Okay, they have two matrices. First one matrix D, and then this a question give to you. Okay, they give you say cargo ships and passenger ships. Like this mean matrix D here, maybe I use this one as a pink color here, right? This is a D. So the question give the first lower column, that mean gonna have 8 and passenger, this one 3 and this 10 and 2. For this one, if you read at the low, right now they assign this one like a dog one, like a port 1 and the port 2, like the location in the seaport, maybe this in the seaport. Okay, and the matrix this one E, matrix E, I give that maybe like blue color here. So the cargo ship in 17, 20, and 5 and 6. This is the question give to you. Find the number of 5D plus 2E. What the information does this matrix give? Okay, so you see, come back to question. The number of ships arrive at the airport, harbor, at the harbor every weekday from Monday to Friday. You see that from this pink color. Okay. From It's every week, right? That means every week from Monday to Friday is giving in matrix D. So Friday to Monday, how many days? 5, right? That's why they loaded 5 here. Okay. So this 5 represent from the question, 5 represent Monday to Friday, Monday, Tuesday, Wednesday, Thursday, Friday. So 5 days, so write down. This represent matrix D. And then matrix E represent what? Matrix E. Okay. The blue color here. Matrix E represent the number of ships. The number of ships arriving on Saturday and on Sunday. So how many days? 2 days, right? That's why they write number 2 in front here. Just say every Saturday and Sunday, they're gonna have like this one cargo ships and the passenger, the 2 items. So then that's why the time, this one is represent what? Saturday and Sunday. And number 5 here represent what? Monday to Friday, have Friday. Monday to Friday. Okay. Okay, so then we start to do, they say A, want us find the matrix 5D pass to E. So not too hard, right? So A, how to do? I get another color here. So we're gonna do question A, right? So you just write down 5D pass to E. Now you write at the matrix pattern, correct? So this one gonna be, you can write 5 outside the matrix first, and then you write matrix D is what? This one, correct? This one, matrix D. We have 8, 3, 10, 2, and then plus 2, matrix E is what? This one, the blue color here. So we have 7, 20, 17, 25, and then 6. Then you can do a lot way after this. You're gonna time and then plus and 2 time, can be that way. Each element at the same location. But I think the easy way to do is time inside first and plus. Okay, like algebra. So you expand 5 times 8, 5 times 8. So this matrix gonna be 40. Okay. And then this one 5 times 3. Okay. Gonna be what? 15. I use same color, I think. So become 15. And then again 5 times 10 become 50. And 5 times 2 become 10. And then plus 2 times 14. 2 times 14. We have 34. And then 2 times 5, we have 10. And then 2 times 20, we have 40. And also 2 times 6, we have 12. Okay, then you simplify. This equal, okay, for this one equal mean 5D part 2E. After this, you just sum it up. You can sum the same location. Sum it up. This sum this, this sum this, okay? So you have, we write down 40 plus 34. Same location, okay, don't forget. 15 plus 10. And 50 plus 40. Also 10 plus 12. And like close it matrix. Then you simplify. 40, 34 becomes 74. 15, 10 become 25. 50, 40 become 90. And 10, 12 become 22. Then that's a final answer for the question as you find the matrix 5D plus 2E. Okay, this is a final answer. And then question B, what information does this matrix give? So this one talk about what? Every day, every week, correct? This one talk about every week, every day, just say every weekday. Okay. Represent what? In just say can say in a week, right? In a week, the matrix, this matrix represent the number of cargo ships. You can say this matrix, the matrix give what? You can write down for question B. You can write your own word, doesn't matter. Is the number of cargo ships and the passenger ships arriving at the dot 1 and 2. That means port 1, port 2 in a week. So in a week, there we always have this shipment, cargo and passenger. So total this simplified now. So you can see this matrix represent the number. You can write down. Okay, write down the number of. Just they happen these two things, correct? You can write down of cargo ships and passenger ships arriving at dot 1 and 2 in a week. Okay, that's the answer for question B. Okay, I think that's all for the addition, subtraction, and the scalar multiplication of matrices. This example, you take a look and then you do my work question, okay? I want your work. Okay, now that's all for today. And I will tell you what question you have to do. Okay, thank you. Bye-bye. You have a good day.